Alright guys, so we're gonna jump right into it. I'm gonna try to keep these videos short just to make it a little bit easier to download or open on YouTube. So with the start of the second semester, and we're gonna treat this week as the start of the second semester, we're going to start with looking at non-renewable versus renewable resources. So there's gonna be a PowerPoint I'm gonna talk through just to give you an idea of how I'm gonna structure these videos. And then from there, once we go through the PowerPoint, what we're going to do is you're going to have a guided reading or some sort of assignment to go along with it. So today's is going to end up being a guided reading to help you kind of make sure you're making these connections and not just skimming through a PowerPoint. So with that being said, I'm going to decrease the camera a little bit here, and we're going to get going. Alright, so first off, here's your starter. Pause the video, answer the questions, and from there we're going to resume. Alright, so you should have answered these three questions and made a determination based off the bar graph. So we have non-renewable resources. Sorry, I have the slide hidden, so let me fix that real quick. So for the bar graph, the highest should have been coal, second highest should have been natural gas, and third highest should have been crude oil. I realize this is somewhat dated. Currently today, we'd probably expect to see natural gas higher, crude oil a little bit lower, coal potentially slightly lower. And I'm going to just jump back slides real quick. So our three fossil fuels you should named off as coal, crude oil or oil, and natural gas. And you should know that all three of these are hopefully non-renewable. And because they are non-renewable, they are a finite resource. So, major things to take away from this lesson. So, different sources can be used to get energy. Determine if a resource is renewable or finite, or renewable or non-renewable, depending on the concept. Consider the impact that using the resources has on our environment, the advantages and disadvantages of each energy source, and how a power station works using fuels, because, well, it's a concept most people don't understand, and I think it's really, really important to understand how it works, at least from a broad macro picture. So you don't need to know like the intricacies, but having a basic understanding of how it works might be useful to you. So, our fossil fuels. This lesson we're going to focus on our non-renewables, or fossil fuels, and the lesson for later in the week is going to be our renewables. That one might be broken into two lessons depending on time. So, our fossil fuels. What do we use these fuels for? Well, crude oil. You know the crude oil is a process thing, so we use it for, in particular, gasoline from crude oil to power our cars. Traditionally, people have used it for things like lanterns, coal. We use for power plants and a number of other things. And natural gas, we use it for cooking. We've seen a major shift towards using natural gas for heating our homes, and so on. So, our major uses, they're burned to generate heat, and we've later found that a way to translate this generation of heat whenever they burn to generating electricity, whether that's in a car, in your home, or what have you. So, our fossil fuels, major advantages. Traditionally, they've been very cheap in comparison to other forms of energy. They've also been readily available, so it's something that we've had access to, like even early on, because fossil fuel power plants have been a thing since the Industrial Revolution. They are relatively easy to ship, whereas I can't ship something like hydroelectric, geothermal, or wind. So if I live in a region that's not windy, I can't use that. Whereas this, I can have it shipped there and use it. It's relatively safe, although there are some major issues that we're discovering that with our fossil fuels, and it's been around forever. So our disadvantages. So shipping costs money. There's a finite amount of fossil fuels, which means we're going to run out eventually. And the last major disadvantage is the environmental impacts. So our first major environmental impact is this idea of acid rain. So whenever I burn my fossil fuel, this pertains more to coal and crude oil than natural gas, but natural gas can have trace elements of sulfur. So whenever I burn this, normally one of the byproducts that we get of our reaction is carbon dioxide. But we also, if I have sulfur content in my coal, have the possibility of burning that sulfur, giving me sulfur dioxide. And sulfur dioxide is bad for a couple reasons. Well, namely one major reason. So if we burn that fossil fuel, we release sulfur into our atmosphere. So that sulfur is going to react with water in the atmosphere. I apologize about the typo. I will fix that on the PowerPoint before I upload it. So it's going to react with water in the atmosphere to make sulfuric acid. Sulfuric acid then mixes with water in the atmosphere and has the ability to come down as acid rain, which then goes on to destroy man-made structures as well as killing plants and animals, as you can see in these images. So you see the distortion in the statue based off of the acid rain. You also can see fish washing up from the water being too acidic and the trees being dead from acid rain. So our second major issue is this idea of global warming, because we know that carbon dioxide is what's called a greenhouse gas. Now, just to reiterate this, so burn carbon in our reaction because we're burning what's called a hydrocarbon. So it's a compound that forms hydrogen, or it's a compound that is hydrogen and carbon, and whenever we burn it, it produces carbon dioxide while also producing energy. So we know that carbon dioxide is a greenhouse gas, and ultimately what's actually happening is my greenhouse gases have the ability to absorb heat that is trying to rise from the surface of the earth back up into space. So what those greenhouse gases do is that they either absorb it or they bounce it back down towards earth. Now some of it still has the ability to escape, but these greenhouse gases, the more there are of them, the harder it is for this radiation to escape, which as our greenhouse gases increase, it leads to an increase in temperatures on Earth, which is where this idea of climate change or anthropogenic climate change comes from. So our last major thing we're going to touch on. So how do fossil fuels generate electricity? So up here we have a diagram showing the normal process of how to get electricity to your home. So everything on the left side is our power station or our power plant. Everything on the right side is what you'd see on a street as a way to get that power to your home. So we're going to start in this bottom left corner. So we put our fuel into this bottom chamber where our graphic says heat, and we're going to burn that. So let's assume that we're using coal. So we heat we burn our coal. That causes the water in the chamber above to boil. So when water boils, we know it turns into steam, and so it's going to evaporate, turn into steam, and it's going to go up into this turbine. That flow of steam continuously coming out is going to spin that turbine, in turn spinning this generator, causing that generator to generate electricity. So we're up through 3. I'm going to move my camera real quick just to make this a little bit easier. So our next one. So the steam in the turbine comes down to this condenser, and it's going to get turned back into water in my condenser and be reintroduced to my water chamber. The energy that's being generated in my generator in my generator at 3 is going to be transferred via wire to a transformer, and then from my transformer it's going to go through power cables, and it's going to go into your home. This is how you get energy in your home. So, with that being said, you are going to have, hold on, sorry. With that being said, you're going to have a guided reading to go along with this PowerPoint. It's going to be due at the end of the week. This is going to be part of it's going to be part of a participation grade, because I've decided moving forward, we are going to do 2 grades each week. One is going to be participation. The second one is going to be some sort of small assessment. So for my participation grade, it's going to be if we're remote, did you do your work? And did you show up for your team's meetings? If you are able to show up to your team's meetings. It's going to heavily favor the work, though. And then obviously the assessment is a small, short graded assignment. If we're in person, participation is going to include you being in person in class, you participating, you doing your work. Those 3 factors. And the assessment would be the same. So, anyways, we're going to keep this format. We're going to have a teams meeting Tuesday at our normal time. So, probably start around like 7:40 to 7:45, depending on if I'm running a little bit late. I'll let you know if I am. All right, guys.